Hi, welcome to clickmyproject.com. Project title is CDAMA, Concealed Data Aggregation Scheme for Multiple Application in Wireless Sensor Networks. Wireless sensor network consists of thousands of sensor nodes that gather data from deployed environments. In this paper, the proposed scheme called CDAMA provides CDA between multiple groups. Basically, CDAMA is modification from Boni it as PH scheme. Here we propose three practical application scenarios for CDAMA, all of which can be realized by only CDAMA. The first scenario is designed for multi-application wireless sensor network. In practice, sensor network having different purposes. Example, smoke alarms and thermometer sensors may be deployed in same environment. We apply conventional concealed data aggregation schemes. The cybertext of different application can be aggregated to other. Otherwise, the decrypted aggregation will be incorrect. The only solution is to aggregate the cybertext of different applications separately. As a result, the transmission cost grows as the number of applications increases. By CDAMA, the cybertext from different applications can be incorporated into only one cybertext. Conversely, the base station can extract the application-specific plaintext via the corresponding secret keys. The second scenario is designed for the single application wireless sensor network. This last scenario is designed for secure computing capability. In previous scheme, the base station does not know how many messages aggregated from the decrypted aggregated results. Leaking count knowledge will suffer maliciously selective aggregation and repeated aggregation. In CDAMA, the base station exactly knows the number of messages aggregated to avoid above attacks. Next, I am going to explain the data flow diagram of the project. Start the process. We are going in data mining project. We are going to connect the data set. In this paper, we collect the two data set. First one is a node 1 data set. Node 1 data set contain node ID, reading, and the temperature value and the humidity value. These values are the sensing results from the node 1. And the next data set is node 2 data set. Node 2 data set contain node ID, reading, temperature value, and humidity value. We are going to encrypt these temperature values only. Before that, we are going to generate a key using elliptical curve cryptographic algorithm. In ECC, we generate two curve points P and H. Using these two curve points, we first generate the public key for the first node, and using the curve point H, we generate the next another one public key and private key. Using the public key, we now encrypt the temperature value into another format, cybertext. Finally, we are going to aggregate the two sensor node cybertext into one cybertext. Data aggregation is important in this project. Aggregated cybertext are now going to send to the base station. And the base station retrieve the aggregated cybertext. Finally, the base station will retrieve the two private key for the two sensor nodes. Using the first private key, we first decrypt the node 1 cybertext, get the plain text, and using the another private key, it will decrypt the another sensor node cybertext. Finally, the base station receive two plain text successfully. End the process. Next, I am going to show the demo of the project. Open NetBeans. This is of the project. Run title.java. This is the title page of the project. Click next icon. Now, in sensing result, we are going to load the node 1 dataset into the databases. Click load. Loaded successfully. Next, we are going to view the node 1 details. Click view. Node 1 dataset contain reading, node ID 1, and then this temperature value sensing from the node 1 data set, and these are the humidity value. Next, click next. Next we are going to load the node 2 data set into the databases. Click load. Node successful. Next click view. These are the node 2 data set. Nodes 2 data set contains same as the node 1. Only difference is the node ID from the 2. Next click next. Now we are going to generate a key for encrypt the node sensing results. Get 3 large prime numbers. The order of n is equal to multiplication of 3 large prime numbers. Select 3 random generators. Calculate the point h. The order of h is Q3. Next calculate p. The order of p is Q1. Click next. Maximum boundary in the sense the total number of data in the datasets divided by the number of application. Generate the public key, store the public key into the databases, and generate the point q for the node 2 encryption. Calculate the point q. Order of q in the sense q2 value. Calculate the public key. Store the data into the databases. Click next. And click. Now we are going to encrypt the values. Click original. These are the original sensor value in the node 1 values. Now we are going to encrypt this temperature value into cybertext using the public key. Encrypted successfully. Next click next. These are the cybertext value for the node ID. These are the reading value. Click next. Get the original value for the node 2. These are the original temperature value for the node 2, in the sense the application 2. We are going to encrypt the node 2 value. Click encrypted value. Encrypted successfully. These are the node 2 value. Node 2 temperature value are going to encrypted. Next click next. Now we are going to aggregate the 2 cybertext into the 1 cybertext. Click aggregate. Aggregated successfully. Now 2 temperature aggregated cybertext into the 1 cybertext. These are the count of the node 1 and node 2. Click send. Now we are going to run the base station.java. Receive the values received successfully. Split the data into 2 separate node values. Click next. Decrypt node 1 private key and get the node 2 private key. Decrypted successfully. Check the original values. Now we are going to get the original temperature value. Now we are going to evaluate the asymmetric elliptical curve cryptographic algorithm execution time is less than the RSA algorithm when compared to the existing approach. In conclusion of the project is, for multiple application environments, CDMA is the first CDA scheme through CDAMA. The cybertext for distinct application can be aggregated but not mixed. For a single application environment, CDMA is still more secure other than CDA schemes. When compromising attack occurs in wireless sensor network, CDA mitigates the impact and reduces the damage to an acceptable condition. Thank you.